Hello all, welcome to the course on Python programming for beginners. We are in module 11, lecture 2. We are going to discuss about the types of constructors in this lecture. A constructor is a special kind of method or function that is used for initializing the instance variables of the class. Python supports the following types of constructors, including default constructors, non-parameterized constructors, parameterized constructors, and constructors with default arguments. So we will be discussing about these 4 types of constructors with the examples. The first one is the default constructor. Python provides a default constructor if no constructor is defined in the program. It does not perform any task, but it simply instantiates the objects. It is an empty constructor without any body within it. Let us consider the example class person. Here, we are not writing any init method. Simply, we are writing a method called as show method, which is printing object instantiated. Outside the class, we are creating an object P1 with the name of the class followed by the open parenthesis. If we write init method, this instantiation should invoke the init method. Since we have not written the init method within the class, the Python invokes the default constructor. So the default constructor, it does nothing. That means there is no initialization done within the default constructor. It is an empty constructor basically. Then p1.show, that means we are invoking the method show on the object P1. Since there is no code that is being executed within the default constructor, no values are initialized for P1, and it simply invokes the method show and prints the statement object instantiated. So basically, the default constructor is invoked by Python when there is no constructor written within the program. The next type of constructor is a non-parameterized constructor. The name itself indicates that we need not pass any parameters whenever we instantiate the object. So basically, non-parameterized constructor does not take any parameters. Let us see an example. Here we are creating a class person and we are writing the init method, which is a constructor. If you observe, there are no parameters other than self. As we have also already seen, any class method should start with the parameter self, which indicates the current object. So other than self, there are no other parameters. That means this is a non-parameterized constructor which is not taking any parameters for initialization. And whatever the values that you want to initialize, those values can be initialized within the init constructor. For example, self.name equal to Rajesh, self.age is 30, self.profession equal to engineer. So whenever we instantiate an object outside the class, person1 equal to person, in that case, person1 will be having the instance variables name, age, and profession initiated with the values Rajesh, 30, and engineer. No matter how many objects you create of the person class, all these objects will be having the same attribute values because these attribute values we are initializing within the non-parameterized constructor. That means we are not allowing the users to pass any parameters for initialization. So such a constructor is called as a non-parameterized constructor. Let's see the print person1.name, person1.age, and person1.profession, it is going to print the values of the name, age, and profession that have been initialized within the init method. Next one is a parameterized constructor. In this case, the constructor allows the parameters to be passed. So a parameterized constructor accepts arguments to initialize class attributes. Let us define a class rectangle. And in this, we are creating a constructor init with the first argument self, and the second and third arguments are width and height. So these two are the arguments that we are accepting from the instantiation of the object. And self.width equal to width and self.height equal to height. That means the width and height of the current object are going to be assigned with the width and height values that are passed whenever an object is instantiated. For example, let us consider rect1 is an object of rectangle class with the parameters 5 and 10. Since we are passing the parameters, it is called as a parameterized constructor. And if you try to print the values of width and height of this rect1 object, it is going to print as 5 and 10. Because for the rect1 object, we are passing the values 5 and 10 as the width and the height. And similarly, let us consider another object, rect2, where we are instantiating by using the values 8 and 20. That means we are passing the parameters 8 and 20 to width and height for rect2. So when you try to print the width and height of the rect2 object, it is going to print the values as 8 and 20. So basically, in the parameterized constructor, we can pass the parameters so that those parameters can be assigned to the instance variables of the object. The next type of constructor is constructor with default arguments. So in this case, we can provide default values for the constructor parameters. Let us see an example. Here we are creating a class car, and in this we are again defining a constructor. So this is the syntax for defining the constructor that we have already seen. _init, _, followed by the list of arguments. The first argument is self, and the subsequent arguments are the make, model, and year, which are the instance variables of the class car. So here if you observe, the make, model, and year are already initialized to the values Toyota, Camry, and 2022 respectively. So here we have again the initialization statements: self.make equal to make, self.model equal to model, self.year equal to year. So whatever the values of make, model, and year are going to be assigned to the make, model, and year attributes of the current object. And let us see the objects car1, which is initialized with no arguments. That means here we are using a constructor with default arguments. If we don't pass any parameters, by default, these values are going to be assigned to the attributes of the object. Since for car1, we are not passing any parameters. So by default, it is going to take the make as Toyota, model as Camry, and year as 2022. On the other hand, for the next object car2, we are passing the two values, Honda and Civic. So only the first two values we are passing. So the make is going to be overridden by Honda. Earlier it was Toyota. Since we are passing Honda as the make, it is going to be overridden. Toyota is going to be overridden. So for car 2, the make is going to be Honda and the model is going to be Civic because we are explicitly passing it. Since we are not passing the year by default is 2022. This is the default value. So, in case of a constructor with default arguments, if the arguments are not passed whenever an object is instantiated, it is going to take the default arguments that are defined in the constructor. And if we pass the parameters, the default parameters are going to be, the default arguments are going to be overridden. And what if there are more than one constructor of the same type within the class? Let us see this example where we are defining the class 1. Here, if you observe, there are two constructors, init and init. If you observe, both are of the same type. That means they are the non-parameterized constructors. We are not passing any arguments here. This init method is not having any arguments. That is why it is the non-parameterized constructor. So both of them are non-parameterized constructors only. So in such a case, it is going to invoke the lastly defined the constructor. That means if we write multiple constructors of the same type, Python is going to invoke the last constructor within the class. For example, if we create an object O equal to 1, in such a case, no matter how many constructors are there, it is going to invoke the last constructor. Since here there are only two constructors, it is going to invoke the second constructor. That is why the output is second constructor. So here it is not going to invoke the first constructor, it is going to invoke the last constructor. Here the second constructor is the last constructor. So if you give it more than one constructor, then in such a case, will not be able to overload the constructor. Instead, the last constructor is called. So we'll see, we'll be discussing about the meaning of overloading in the subsequent classes. For now, you understand that whenever there are multiple constructors of the same type are defined within the class, in such a case, Python is going to invoke the last constructor in the class. And what if different kinds of constructors are used within the class? In this example, you can observe here in the class 1, we have one constructor which is init _init _self. This is a non-parameterized constructor. And the second type of constructor is a parameterized constructor, because in this case, we require one parameter to be passed. So here we have self.val equal to value and print second constructor with the value. So in this case, if you create an object O equal to 1, where we are not passing any parameters, Python searches for the last constructor. So here the last constructor is what? It is a parameterized constructor which requires one parameter to be passed. But whenever the object 1 is created, we are not passing any parameters. That is why it gives an error. Python is going to invoke only the last constructor if the signature of the object creation does not match with the signature of the last constructor. In such a case, it gives an error, because here there are no parameters, whereas here the last constructor requires one parameter. So there is a mismatch, so it gives an error. So here init missing one required positional argument value. Since it is going to invoke the last constructor which requires one value, here we are not giving that one value, so it is the error. Now let us see the demonstration of different types of constructors with examples. So let us see the demonstration of different types of constructors here. Here we are initializing a class variable without a constructor. So if we don't write a constructor, we already have seen that whenever you instantiate an object, it is going to invoke the default constructor. But here we are not instantiating the object, simply we are assigning the value CBIT to college_name. So we have the class person where there is only one variable college_name which is initialized to CBIT. So here there is no self, right? So in such a case, we call such variable as the class variable. So class variables are like global variables which are shared by different objects of the class. So you can print the class variable by using the name of the class. So print person dot college_name. So in this case, college_name is the class variable. And let us look at the default constructor. Here we are defining the class person, but here we are not mentioning any init method within the class. Simply we are writing a method show. And when we create an object p1 equal to person, in such a case, Python invokes the default constructor with the no body, that is an empty constructor, and it is not part of the program. Since we have not written in the program, it is going to invoke the default constructor, which is implicitly done by Python, and p1.show. So here, invoking a default constructor by Python, it simply does nothing other than instantiating the object. So it simply creates an object. So once the object is created, you can invoke the methods of the class by using the name of the object. So here p1.show, it is going to invoke the show method of the person class, and it is going to print object instantiated. That is about the default constructor. Next is the non-parameterized constructor. Let us see this. So this is the non-parameterized constructor where the init method is not having any arguments other than self. So self is a mandatory argument that is required for any class, method, or a constructor. Other than self, there are no parameters. That is why it is called as a non-parameterized constructor. And this person class is having the attributes name, age, and profession. And these are initialized to Rajesh, 30, and engineer. So when we create a person1 object by using the name of the class person, it is going to invoke the init method where the name, age, and profession of the object person1 will be initialized to these values. So when we try to print the name, age, and profession of person1, it is going to print the values which are assigned within the init method. So in this case, no matter how many objects you create, all these objects are going to have the same set of attributes because they are static. We are not allowing any parameters to be passed. On the other hand, the parameterized constructor, we can allow the parameters to be passed whenever an object is instantiated. So let us consider the example class rectangle. In this case, we are writing init method which is taking two parameters, width and height. Self is self refers to the current object, which is a mandatory argument. Self dot width equal to width and self dot height equal to height. So we are creating two objects, rect1 and rect2, and for rect1 we are passing 5 and 10 as the width and height, and we are printing the values of width and height of rect1, and then we are creating another object rect2 with width and height values as 8 and 20, and we are printing the values of width and height. So in this, what you need to observe is whatever the parameters that are passed whenever an object is instantiated are going to be assigned to the attributes of that object. Next one is the constructor with default arguments. Here we are writing the init method with the first argument as self, and the car class is having three parameters or three attributes, which are make, model, and year, which are already initialized with some default values. So here the default values for make is Toyota, for model it is Camry, and for year it is 2022. So these are the default values. So if you don't pass any values whenever you instantiate an object, these default values will be assigned to the attributes of that object. So again here we have self.make equal to make, self.model is model, and self.year equal to year. So this Toyota is going to be assigned to self.make, and model Camry is going to be assigned to self.model, and year 2022 is going to be assigned to year attribute of the object by default. That means if you don't pass any parameters. For example, here in case of car 1, we are not passing any parameters. That is why it is going to assign these default values to car 1. And similarly for car 2, we are passing two parameters. So it is going to consider in the order of appearance of the default, the attributes with default arguments. So here make is going to be overridden by the value Honda. Earlier it was the default value was Toyota. Since we are passing Honda, this Toyota is going to be replaced with Honda, and this Camry is going to be replaced with Civic. And anyway, we are not passing any value for the year, so it is going to be same as 2022 only. So when we try to print the make, model, and year of car 1 and car 2, you can see the output Toyota Camry and 2022, which are nothing but the default values. Here the newly passed parameters are assigned to the make and model of car 2. And one more thing is, whenever you define multiple constructors, Python always invokes the last constructor. Here we are writing two constructors, first constructor, second constructor, and we are creating an object P1 equal to person. So if you execute this, it is going to print it as the second constructor. No matter how many constructors you write, it is always going to invoke the last constructor only. For example, if we write another constructor, say define init __ self, we are writing the third constructor here, print third constructor. So, and when we create an object P1 equal to person, in this case, it is going to invoke the last constructor, which is the third constructor. Now, if we try to execute this once again, it is going to print it as the third constructor. So likewise, no matter how many constructors you write within the class, Python always going to invoke the last constructor only. Let's see another example for having different types of constructors in the class person. So here we are writing one constructor with no parameters, which is a non-parameterized constructor, and the second one is a parameterized constructor. So Python has to invoke the last constructor, which is the parameterized constructor in this case. That is the second constructor, which is initializing the value of name to the name is going to be initialized with whatever the argument that is being passed. Now, if we create P1 equal to person, here person is not having any parameters, but the last constructor that we have defined within the class requires a parameter. So if we try to execute this, it is going to give an error. So it is saying that missing one required positional argument. On the other hand, if we create an object, say P1 equal to person with some value, say Ram, in this case, it will execute successfully because here Python is going to invoke the last constructor and that last constructor is requiring one parameter. So if we pass that parameter, there won't be any error. Similarly, let us create another object P2, which is initialized with the value Chaitanya. So if you run this code again, in both the cases, it is going to execute only the last constructor only. So with this, we came to the end of lecture 2. So in this class, we have seen 4 different types of constructors, which includes the default constructor, which is invoked by Python whenever there are no constructors defined within the program. Then we have non-parameterized constructor, which does not take any parameters, and parameterized constructor, which allows the parameters to be passed whenever an object is instantiated. And the last type of constructor is constructor with default arguments, where some default values will be assigned to the attributes. And if no parameters are passed whenever an object is instantiated, these default arguments will be assigned to the attributes of the object. And when multiple constructors of same type are defined in a class, object instantiation of that class invokes the last constructor that we have seen with the example. And when different types of constructors are defined, an error occurs if the object instantiation does not match with the lastly defined constructor in the program. So with that, we came to the end of this lecture, and we'll meet again in the next lecture. Thank you.